situation, we discussed that, okay, how this particular multiple access can be given when a link is shared by the multiple users. And so it should be in such a way that, okay, so best utilization, because the point is everyone should utilize the link, and but at the same time there should not be any collision and all, like what for that particular purpose. So we have discussed the random access protocols and controlled access protocols, where we are talking about collision free protocols and all. And here we are going to have another some protocols like channelization protocols. Okay, basically these are not available in your Forojan, in your Tenenbaum, but in the Forojan they have specifically explaining this particular thing. Okay, so now I'm asking the question to you people that whether you want to learn about this channelization protocol, or shall I go through with the next topic? I'm asking all of you.
Explain, sir.
Okay, so fine. Okay, so what is this channelization protocols? Now here, if you are going to look at that, so this is FDM and TDM, you know, frequency division multiplexing, which is a time division multiplexing. And what is this CDMA? Code division multiplexing. Dear friends, I hope you know that today you are going to use GSM, isn't it? So, but actually before this particular, whatever the SIM which we are using in the mobiles, before that we are going to have a CDMA. Okay. So now here, if we are going to look at this particular thing, okay. Before we are going to discuss about this channelization, I'm going to ask that any doubts in these particular protocols? Any doubts in these particular protocols? Be fast, put it into the chat. So thanks a lot for everyone for giving your responses. If you have any doubt, okay, you can ask me, no problem. But when we are going to talk about this particular channelization, okay, so now here we are going to look at the frequency division multiplexing. So once if you will try to understand what is the frequency division multiplexing, okay. Now, based on frequency division, the name itself is suggesting that, okay, so we are going to divide the link based upon the frequencies. Okay, so now here under the channelization, what we are going to do in the sense, the multiple access method in which the available bandwidth of the link is shared in time, okay, or frequency, or through code between different stations. Now this is what exactly you need to understand. So we are going to use this particular thing either by using frequency. Okay, so whenever I'm talking about a frequency, the radio is coming into your mind, no problem at all. Okay, and so even when I'm going to talk about time, whenever I'm talking about time, timetable should come into your mind. Okay, and then another one when we are going to talk about code. Now these are the three very important aspects. Okay, so now here if you are going to look at that, frequency division multiple access, time division multiple access, code division multiple access. Now when we are going to talk about this, how FDMA is going to work. Okay, so now when we are going to look at, when you are going to look at the frequency division multiplexing, now here everyone please try to look at that. So if the four channels are there, this is the one particular if this is the one particular node, and this is the two, this is three, and this is four. How many nodes are there? Four nodes were there. Okay, and all these four would like to use one channel. Then what we are going to do, for every channel, for every node, we are going to give a different color. You see, we are going to give a different color. Okay, so blue, green, yellow, okay, pink, okay, like that, some different colors we are going to give. So now whenever in a particular time, if suppose t is there, what if we are going to do, if four are there, we are going to divide the t by 4 according to just now whatever I have told over here. Okay, see, we are going to share, okay, in time, frequency, or code. Now when we are going to are going to look at over here in the frequency, whatever the frequency is there, if suppose one frequency is there, now that frequency we are dividing it into the four parts. Okay, and each part we are assigning it to one. Now here if you are going to look at that, this is a frequency. Okay, so this is the time. So I'm going to divide it and we are going to give it that. So whenever this particular first node is getting its frequency slot, only in that slot it should send the data. Same way the second one, same way the third. If third is not having it, see right now it is a silent, so it is not going to send anything. It is empty. Okay, consider if it is having a data, it can send it. Okay, if it is having a data, it is going to send it. Okay, so now multiplexing, that is nothing but all these four data nodes, whatever it is going to give a data, and when I'm combining it, this particular complete data, then I can say that this is the t time. Okay, in the t time, I'm going to get it. So this is the number of nodes we are having it and all. So now in FDMA, what we are going to do, the available bandwidth, we are going to divide it into bands. Okay, and that are separated by God bands. What is the meaning of God band? Now here if you are going to look at that, if you are going to look at that, if suppose this is a frequency 1, if this is a frequency 2, if this is a frequency 3, okay, if this is a frequency 4, we have divided. Okay, we are dividing the four data nodes, each one it is going to get a different frequencies. Now I need to combine these particular things. So for that particular purpose, when I'm going to combine like this, okay, when I'm going to combine these things like this, okay, so now these things I'm going to call it as God band. What we are going to call it as God band. Now this God band is going to connect the different frequencies. Okay, because FDMA, what we are going to talk about, frequency division multiple access. Now how all these frequencies can be combined over here, see the spaces between it is there, so I need to add this God band. Okay, I need to use the God band to combine these particular frequencies. Now that is nothing but extra bit of information I need to use this particular thing to combine. So in this particular situation, now what exactly is going to be happen? Okay, now here if you are going to look at, okay, now here if you are going to look at that, so FDMA, we are going to use this particular thing into this. Okay, 1 minute, I have opened some other book. Okay, so now here when we are going to look at so this particular important point, when we are going to use majorly these things where we are going to use, okay, so how we are going to use these particular FDMA, TDMA and all, that is nothing but in the cellular phone systems which we are going to use, that maybe in another chapter which we can discuss in detail. But right now you can imagine that, see, each station is allocated a band to send its data, and whatever the band is allocated, only in that particular time frame only it can send the data, and these data are going to be combined. Okay, these are going to be separated, means how we are going to say f1, f2, f3, f4, both are going to be joined by using the God band. Okay, now here if suppose we are going to look at that, what is a God band? Okay, now here if you are going to look at what is a God band, okay, see, what is a God band? A God band is an unused part of the radio spectrum between radio bands. Okay, that is what I have shown to you people over here. Now here if you are going to look at that, these are unused. That is nothing but extra bit of information. Okay, in the radio bands for the purpose of preventing interference. Okay, and this is going to be used over there to join that particular frequencies. Okay, so now when it will comes to that, now here when we are going to look at that, FDMA and FDM are both are same, which FDM which we have discussed in the previous classes also. Now I have divided it into the frequency. Now please try to understand, one frequency is allocated to one particular node. Okay, so one particular station, one band. Now in that particular band, it does not have any data to send. What is going to be happen? The band is wasted. The band is wasted. Okay, now the ultimately when we are going to look at that, each station tells its physical layer to make the bandpass signal from the data passed to it. Now, the signal must be created in allocated band. So that is what I have explained. Whatever the band is allocated, only in that you need to send it. Okay. And another important point is, if you do not have any data to send it, what is going to be happen? Simply it is going to be wasted. It is going to be wasted. So now how we are going to achieve the greater bandwidth? Okay, same way, if you are going to divide it into the time, if you are going to divide that particular thing based on to the time. Okay, so now the t by 4 I am going to do there. We have done this particular thing as a, instead of this t, what you can do in the sense, I can say that this frequency, okay, I can say that over here it is a frequency. Okay, this frequency we are going to divide, and so we are going to use this particular thing as a frequency band. Okay, we are going to talk about that frequency band. Okay, now same way, see here we are going to do time. Okay, the time, if suppose 60 seconds is there, now each one is going to get how much time. Okay, if suppose t, okay, t is 1 second, if we are going to divide 1 second by 4. Okay, so what is going to be happen? So each one is going to get 15 part of a 15 particular second. Okay, so then it is going to collect the data from that particular station within that particular time period, and then which is going to be combined like this. Okay, this is what we are going to call it as a time division multiplexing. Okay, multiple access. Now time division multiple access example, what I told, the timetable. So according to the timetable, okay, now here I have allocated for the first slot, second slot, third slot, and fourth slot. Now imagine if the third slot is not having any data, so this particular time is waste. Any other can utilize it? No. So that cannot be utilized by anyone. So that was the reason. Now here what we are going to do in the sense, we need to look at how we can overcome this particular thing. Okay, where we are going to have STDM and we are going to have a STDM. We are going to use STDM and STDM. What is STDM and STDM? Statistical time division multiplexing versus synchronous time division multiplexing. There we will see that how we can utilize this particular empty spaces also. Okay. Now that is the advanced one. But right now you can understand the time division multiplexing, and this is going to be divided into the time. Then the third one is the code division multiple access. In this code division multiple access difference, you please, I hope you can imagine, before this particular GSM mobiles, okay, we have CDMA mobiles, which is not going to work in a every area, but only within that particular city it is going to work. Like you are going to have Reliance CDMA phones, Tata is also is having the CDMA phones. How this CDMA is going to work? Code division multiple access. Okay. Now here, what is going to be happen? One channel, when we are going to talk about one channel, carries all transmission simultaneously. How? You can have a look at that. Now, the simple idea over here is every channel you are going to have a data and you are going to be given code. Now, if suppose you are going to have a mobile, okay, for that particular mobile, I'm going to give a code, okay, and same way for the station 2 also you are going to have data and you are going to have a code, and station 3 also you are going to have a code, and station 4 also you are going to have a code. Now, code division multiple access, what we are going to do in this particular data, so you are going to multiply your D1 into C1 plus D2 into C2 plus D3 into C3 plus D4 into C4. Now when you are going to multiply those things and when you will combine that, and then this particular data is going to be shared through that particular common channel. Okay. Now when you are going to do such kind of a thing, then this is going to be called as a code division multiple access. We are going to call it as a code division multiple access. Okay. So now sir, how this code is going to be there? Like we are going to use the chip sequences. Now the chip sequence for C1, C2, C3 and C4, you can have a look at that. Okay, plus one, plus one, plus one. See, every chip is not going to have the same. C2 is going to have different, C3 is going to have a different, C4 is having a different. Now here if you are going to look at that, all the four chips are not having the same. Now when you are going to take an example, data representation, when you are going to use in the code division multiple access, a 0 is going to be represented as -1 and a 1 is going to be represented as +1 and the silence is going to be represented as 0. Okay. Now you can please try to remember, 0 is silence, +1 is for data and -1 is for 0 bit. -1 is for 0 bit, +1 is for 1 data bit. Okay. -1 is for 0 data bit and 0 is for silence. So majorly we are going to keep our things into this only. This is silence. Okay. Now if you are going to look at an example, okay, if you are going to look at an example, okay, now here what is there? Bit 0 is a data. Then 0 is going to be represented as what? You can have a look at that. Okay, you are going to have the data bit as 0. 0 is going to be represented as -1. Okay, so now your 0 is going to be represented as -1 and your C1 is this one. This is the code. When you are multiplying D1 into C1, you are going to get this. You can check, -1 into +1 +1 +1 +1 is -1, -1 -1 -1. The same way, now here also you are going to have a 0. This is -1. Then you are going to multiply with the C2. You are going to get this. And then, so here silent 0. Okay, silent is going to be represented with 0. So anything you are going to multiply with the 0. So that is nothing but 0 only. And here bit 1, this is the bit is 1. So that is nothing but +1. Now +1 is supposed to be multiplied with the C4 chip sequence, and then you got this one. And when you are combining this D1.C1 plus D2.C2 plus D3.C3 plus D4.C4, whatever the data you are going to get, this particular thing you are going to send it through the channel. This you are going to send it through the channel. Okay. Now the ultimately, sir, we are sending it, but how it is going to be divided? See, the digital signal created by 4 stations in CDMA. Now here if you are going to look at that, okay, so the ultimately the data on the channel, it is coming like this. Okay. Now how the decoding is going to be done? See, the moment if you have received this received channel is going to be encoded into like this. Okay. Then so it is going to be station 2 code, and then it is going to eval. So here if you are going to look at in your, so now here if you are going to look at that, see, we are not choosing the sequence randomly. They were carefully selected and they are controlled. Okay. In this, now each sequence is made of n elements, and where n is the number of stations. Now simply here how you are going to do, if you are going to multiply with 2 and if you are going to do, okay, how it is going to be happen, they have explained, and the data representation you have seen, and we are going to choose that particular thing with a logic. Now these are the signal levels, how you are going to get it. So now how it is going to be decomposed. Now here if you are going to look at that, station 3 can detect the data sent by station 2 by using the code for station 2. Now how you are going to do that? The total data on the channel are multiplied by the signal representing station 2 chip. Okay, chip second chip code to get the new signal. And here The station then integrates and add the area under the signal to get the value -4, which is divided by 4 and interpreted it as a 0. Now here if you are going to look at that, so whatever the third station, if you want to access, whatever your station code is there, with that station code you are going to multiply, and then when you are summing the values, you are going to get this particular thing -1. So ultimately you are going to get your 0. Now here, dear friends, see here, if you are going to look at that, now you can look at whatever the data you are going to have over here. See, whatever the data you are going to have over here, that data is going to be multiplied by with your station 2 code. So, and here when you are going to use the inner product result, okay, now this inner product result you are going to get over here as -4, and this -4 divided by 4 is -1. -1 is nothing but what is the bit you are going to you have sent with this particular station 2, that is 0. So it is going to get the 0 over here. Okay, so this is how exactly it is going to be happen, and if you want more you can go through with that particular. So there are some walls table you are going to use, and how you are going to do the inner product. Okay, see here, this is a very important one, inner product. Okay, this you can have a look at over there. Now this is what we will call it as code division multiple access. We are going to call it as code division multiple access. Okay, so now any doubt in this, everyone? Fatapat, channelization, frequency division multiple access, time division multiple access, code division multiple access. Everyone respond in the chat. Any doubt in the frequency division, time division, and code division? See, in the frequency division, we are going to divide the frequency by number of stations, and whatever the band which we have allotted to the each station, only in during that particular band only it is going to transmit the data. And when it will comes to the time, the same way what is happening is the time is going to be divided by the number of stations. So ultimately our intention is shared. Okay. So now, thank you everyone for responding. Now the ultimate important point is these are the protocols which are going to be used to provide for the multiple access. Okay, but how these are going to be implemented, how these are going to be implemented in our network, in our network. Now that is going to play a very important role. That is going to play a very important role. Okay, now here if we are going to look at that, so when it will comes to our network, okay, majorly we are going to implement these particular protocols. Okay, so we will look at the Ethernet. Okay, so now so far we have discussed about how the channel allocation protocols, okay, is going to work, like aloha. If we are going to talk about pure aloha, slatted aloha, or otherwise carrier sense multiple access, or carrier sense multiple access by collision divide division, and or otherwise for wireless network, carrier sense multiple access by collision avoidance, and we have seen the bitmap protocol for collision free protocols, and like even we are going to have binary countdown method, or we have seen limited contention protocol, or we have seen adaptive tree walk protocol, or otherwise we have seen the reservation, we have seen polling, we have seen token passing. These are the various different protocols like channelization protocols, FDMA, TDMA, and CDMA. All these protocols we have seen that, but how these are going to be used in our this. Okay, so now here it is the time to see how these principles apply in real systems. Okay, so now in the real systems, when we are going to talk about our network, we are going to have what? LAN, MAN, WAN. Okay, see, designed to personal, local, metropolitan, okay, area networks. Now when I'm going to talk about the local area networks and metropolitan area networks, majorly these are under IEEE standard. When we are going to look at IEEE 802, okay, we are going to have so many standards available under that 802. Okay, but majorly when we are going to look at for our LAN, 802.3 is Ethernet. Is Ethernet. And here, when we are going to look at the switched Ethernet, before that particular thing, you need to understand the couple of protocols, okay, and some information. Now, let us have a look at how this is going to be done. Okay, so we need to understand the two important protocols. One is the HDLC and another one is the point to point protocol. Okay, those are going to provide that. So when we are going to discuss for the wired LANs and based on the Ethernet, this is also 802.3. Please try to understand. Okay, let me IEEE 802.3. Okay, so now when we are going to talk about how it is going to be, see, to set the standard to enable the intercommunication along equipment from a variety of manufacturers. Okay, now when we are going to talk about the data link layer of major LAN protocols, now here we need to understand one important point. So your data link layer is going to be divided into the two parts. Already I have told that one is the LLC logical link control protocol and another one is the MAC protocol, medium access control. Okay, so medium access control protocol, and this is going to be different for each and every different networks. Now here, if you are going to look at that Ethernet physical layer, Ethernet MAC, if it is a token passing physical layer, it is absolutely depending on that. No, it is maintaining the transparency over here. Okay, depending upon your lower level. So that was the reason always your MAC is going to take care about lower level, your LLC is going to take care about your upper layer. Now, when I'm going to talk about this lower layer, okay, so this media access control, it is going to take your this particular thing into picture. Now, we need to look at the LAN. Okay, when we need to look at the LAN, okay, please note down. Everyone, please note down. This is a very important protocols which we are going to discuss in a couple of moments, so you can easily understand. Okay. So widely used data link protocols. Widely used data link protocols. One is the HDLC, high level data link control protocol. Okay, which is a bit oriented protocol, which is a classical bit oriented protocol. Okay, whose variants have been in use from decades in many applications. We will come to know. One is the HDLC and the second one is the PPP, point to point protocol, and which is going to be used to connect home computers to the internet, which we are going to use. These are the two protocols we are going to discuss in today's class, HDLC and PPP. Okay, so now let us go through with this particular thing. Majorly, see, they are all derived from a data link protocol first used in IBM, that is called SDLC. What is SDLC? Synchronous data link control protocol. So after developing it, there are a lot of modifications were there. IBM submitted it to the ANSI, ISO, and for acceptance of US international standards. Later, there is a lot of changes into that, and ANSI modified it to become ADCCP, that is Advanced Data Communication Protocol, Data Communication Control Procedure, and ISO modified it to become HDLC, High Level Data Link Control, and so CCIDT adapted to the modified HDLC for its LAP, link access procedure. And finally, so we are going to compatible with the later version of HDLC. Finally, we are going to use this bit oriented protocols. All are the bit oriented protocols, but we are going to use HDLC. When we are going to talk about bit oriented, that is nothing but the bit stuffing in the framing which we have discussed that. Okay, so all the bit oriented protocols use the frame structure. Okay, so now frame structure is nothing but we have discussed that every frame is going to have what? A header. Okay, a header, and it is going to have a trailer. Okay, so this is the frame, and here it is going to contain the payload. It is going to contain the payload. Okay, so this is the frame structure which is going to be used. So how this HDLC is going to have a frame structure? Now we are going to discuss the frame format. Please note down the frame format of HDLC. Or you can use this particular thing also, HDLC frame format. Everyone, please, either you can note down which is comfortable to you, okay, which I am going to use this one, okay. The Mac frame, we are going to have a preamble, and we are going to have SFD, destination address, source address, and length PDU, data and padding, and CRC. CRC. Now here, if suppose you are going to look at in your this, you can have a look at. Note down that preamble. We are going to have preamble. That is the start of frame. Then destination address, source address, and length, data, and pad, and checksum. Now here you please try to keep this in your mind. 8 bits. Okay, 8 bytes, 6 bytes, 6 bytes. Why we are talking about these addresses? These are MAC addresses. Your MAC address is 6 bytes long. That is nothing but 48 bits. Okay, and each frame may contain from 0 to 1500 bytes. Okay, so this is what exactly you need to understand, that every frame is going to contain only 1500 bytes of data. Okay, anyhow, I will explain in detail to you people. Okay, now here every frame is going to start with some data. See, here we are going to have addresses, which you are going to have source address, destination address, and all. We are going to have control information. Okay, so now the ultimately what I can say is over here, see, your address and your control, your upper layer data, and your FCS, and which internally, which is going to have, if it is LLC, it is going to have destination source service access point, and source service access point, and control and upper layers, and this one. Now here, if you are going to look at a standard Ethernet, which is going to come in various ways. Okay, we will come back and we will discuss. Okay, we will discuss first this, and then we will come back to that. So here, if you are going to look at the frame format, the first part is address part. First part is, now here you need to understand the address part, and this is the starting of the frame. We are going to keep, okay, 0610 to identify that, okay, how we are going to use the framing concept, bit oriented. Okay, we are going to use a frame check sequence, and we will say that, okay, to synchronize, we will send some bits over here, and whenever 0 and 5 6 ones and zeros are there, that we are going to take it as a starting of the frame. The same way we are going to use over here. And here, when we are going to use the address field, now here the we are going to use for the destination and source to identify which terminal we are sending, and that. Okay, so in a point to point, it will be distinguished. We will come back. And then when we are going to use the control field is going to be used for the two purposes. One is you are sending a sequence number. You will send a frame, or you are going to expect the acknowledgement. Okay, so the control field is going to be used for this particular purpose. Either you can send the sequence numbers, or you can get the acknowledgement number from that. And then you are going to have the data field. The data field is going to contain from the 0 to greater than, and which is going to have the limitation of 1500 bytes over here. Okay, in each frame, depending upon your this, which we are discussing, that do not forget about that. We are discussing IEEE 802.3 standard Ethernet. Okay, so now the checksum field, which is a CRC, which we are going to talk about, cyclic redundancy code. Okay, CRC code, which we are going to use either 16-bit over here. Okay, so this is the thing, and here we are going to use, every frame is going to be delimited by the 6 ones, 0610 to identify the start and end. And whereas in the point to point, we are going to use a specific flag sequences to that. And so at the same time, the minimum frame contains 3 fields and the total 32 bits. Okay, excluding the flags on either end. So now these frames are going to have the types, to indicate whether it may be a information frame or whether it may be a supervisory frame, whether it may be a unnumbered frame. Okay, when we are going to talk about the information frame, okay, which is going to contain the information, we will look at that. And control fields are also going to have three kinds. Okay, so this is what exactly P is poll, F is final. This is sequence. Okay, this is the type, and here you are going to have this particular thing. What is P by F? Polar final. Okay, so if you are going to look at that, each and every point in detail, when we are going to look at that, these protocols are going to use the sliding window. Okay, and which are going to use a 3-bit sequence numbers. Okay, and it is going to use the 7 unacknowledgement frames can be outstanding at any instant, because I am going to use a 3-bit sequence. Now that is nothing but 0 to 7. That is nothing but 0 to 7. So that was the reason 7 unacknowledgemented in the sliding window. How many you can send it? That is nothing but majorly unacknowledgemented you can send at a time 7, and then you need to wait that. Okay, and here the sequence field in this particular thing, the previously which I have shown, is the sequence. And whenever, if you are going to send the sequence and the next frame which you are going to send both together, acknowledgement, you are acknowledging for the frame and you are expecting the next one, that is calling it as piggybacking. We are going to call the next field is piggybacked acknowledgement. Piggybacking is nothing but what? To reduce that, okay, we are going to send the sequence plus acknowledgement. When we are going to send the sequence plus acknowledgement both together, then that particular frame we are going to call it as a piggybacking. We are going to call it as a piggybacking. And P and F is what I said, poll and final. This we have seen already in the controlled access protocols. So poll and final, okay, polling is the one particular mechanism we have used that. Okay, now, so it is used when a computer is polling to a group of terminals. I told to you in the previous classes that the same concept which we are going to use over here. Okay, so the final one is set to yeah, until and unless, okay, it is going to be happen. So the various kinds of supervisory frames are also available, are distinguished by the type field. We are going to have 4 different types of fields. Okay, so type 0, type 1, type 2, type 3. What is this type 0? Please try to understand. Type 0 is receive ready. I am ready to receive. Okay, type 0 is an acknowledgement frame, officially called receive ready, used to indicate the next frame expected. And this frame is used when there is no reverse traffic to use piggybacking. When there is no piggybacking means the first frames when you are sending it, so you can use the type as 0, that is nothing but receive ready. Then type 1 is, you can see, officially called reject, negative acknowledgement. Type 1 is for negative acknowledgement. I am not ready. Okay, it is used to indicate that a transmission error has been detected. The next field indicates the first frame in sequence not received correctly. Okay, so that that frame can be retransmitted, and the sender required retransmit all outstanding frames starting at next. Now that is nothing but what? Selective repeat, which we have discussed, that go back and selective repeat. Selective repeat is nothing but only that you will send it. But here what it is started talking about, retransmit all outstanding frames starting at next. Now that is nothing but it is going to use go back n, go back n, like this. Okay, then type 2, when we are going to use the type field as 2, receive not ready. Okay, maybe everything is correct but I am not ready. Okay, so it acknowledges all frames up to but not including next, just as receive ready. Okay, so now receive ready, it is going to say that it is by accepting that, and it is telling you that to send the next frame. But here it is going to say that receive not ready is nothing but whatever you have sent to up to that, it is okay, but next one it is not ready. And so there are some problems maybe with the receiver, so that was the reason it is going to say receive not ready. And whenever you want to send, whenever you want to tell that, then you need to use the type 2. Then type 3, when you are going to use selective reject. Okay, so whatever the frame you have received, it is not received correctly, or it is out of the sequence or something. Okay, in that particular situation you need to retransmit. okay, by using the selective reject or selective repeat. Okay, so that is what exactly the type 3. So now HDLC and ADCCP. Okay, anyhow, our main intention is not to discuss ADCCP. Our main intention is to HDLC. Now HDLC allow this frame type 3. Now this is what you need to understand that. Okay, and type 3 frames are undefined frames. Okay, and so that is the information frame we are going to have. Then we are going to have unnumbered frames, and in the unnumbered frames, now we are going to have the third class of frame is the unnumbered frame. Okay, and which is going to be used to pass control purpose. Okay, but can also carry data when unreliable connectionless service is called for. So this is majorly it is going to use to carry the control information. Okay, and when we are going to look at, so like SNRM, set normal response mode, you can set it and then you can send it. And FRMR, that is nothing but frame reject. Okay. So you are going to use the commands and responses. By using that, you are going to use this particular thing. Okay. That is what exactly we will call it as unnumbered frame or control frame. Okay. So ultimately, this is the way how HDLC is going to work. So how this HDLC is going to provide, how this particular frame, okay, we are going to keep it the control frame, control data, we are going to keep addresses, we are going to keep it, okay, and how it is going to allow the data to send. Now here you can have a look at ultimately. So this is a frame. This is a frame where you are going to use this address and control. And when you are using the frames, you are going to have in the HDLC, we are going to have three different types of frames. Okay, so one is for the supervisory frame C, where one is for the information frames, one is the supervisory frames, one is the unnumbered frames. Okay, and in the information frame, it is going to carry the information, but when it will comes to the supervisory frame, okay, we are going to use the different fields type and the next fields and everything, and based upon that we are going to do, and then we are going to have the unnumbered frames, and this is what exactly the HDLC. Same way, when you are going to look at the point to point protocol, point-to-point protocol handles error detection, supports multiple protocols, allows IP addresses to be negotiated at connection time, and permits authentication, and has many other features. Now that is the reason whenever you are going to connect your personal computer with the internet and all, it is going to ask you to enter your username and password. That is authentication, which is not available in your HDLC. So like that, your PPP is going to provide all this particular information. So now how this is going to be provided? Your PPP is going to provide three features. What is that? The first one is the framing method. Okay. So the end of the one frame and the start of the next frame, and the frame format handles this error detection. Okay. So framing method that unambiguously delineates, okay, the end of one frame, and that it is going to take care that you can have a look at that. We have kept some frame check sequence and all. Then the link control protocol for beginning lines of testing, lines up, testing them, negotiating options, and bringing them down again gracefully when they are no longer needed. So this protocol is called link control protocol, which we are going to use that. It supports synchronous and asynchronous circuits and byte and bit oriented encodings. Okay. And the third is the negotiate, the network layer options, which address you are going to use, the IP addresses. Okay, so that is nothing but network control protocol for each network layer supported, and which is going to be used like this. Now that is the reason here, if you are going to look at that, your client system is going to be used the dial-up telephone line, okay, where it is going to provide a specific IP address to you, and which is going to be mapped, and you are going to connect with this particular end server, that is the ISP office, internet service provider office, and how you are going to connect. So when you are using this dotted lines, this is a point to point, and this is where we are going to use, and the point to point format, as I told that starting of the frame and ending of the frame, it is going to use the flag, and it is going to use the checksum for the error detection and error correction, and this is the source address and for destination address, and But whenever you are using all ones, this is a broadcast address. Please try to remember, whenever you are using these addresses, called as broadcast addresses. Whenever these control addresses which you are going to use, we are going to have the control purpose. And here, if you are going to look at that, we are going to have so we will have that. See the control field, the default value for which is this, and this value indicates it is a unnumbered frame. This is a unnumbered frame. Okay, and the protocol field which is going to be used for which protocol which you are going to use, what kind of packet is in the payload field and all, like so codes are defined for your LCP, NCP, IP, IPX, like that. Okay, if you want, we will look at one example also. Now this is what how exactly it is going to be happen. So protocols are going to start with 0 bit or the next layer protocols such as IP, IPX, OSI, CLNMP, and XNS, like that. And so these are the two protocols anyhow. Okay, so these are the two protocols which we are going to use that particular thing, HDLC and that. Based upon these protocols, okay, based upon your this HDLC or PPP, what we are going to do in the sense, we are going to divide your Ethernet, okay, your Ethernet into types. Okay, so now when you are going to look at this Ethernet, okay, standard or traditional Ethernet, which is going to have its own MAC layer and physical layer. Now this Ethernet is going to come in 4 variations. See how Ethernet is evaluated: standard Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. When you are going to look at the standard Ethernet, 10 Mbps, fast Ethernet, 100 Mbps, gigabit Ethernet, 1 Gbps, 10 gigabit Ethernet, 10 Gbps. Dear friends, if we are going to look at in our campus, we are started using this. When college was started, we have used this. In middle, we have upgraded to this, but now we are at present we are using the 1 Gbps, okay, in our campus Ethernet. But when you want to look at one particular standard Ethernet, if you will look at, then you can easily understand the fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. Easily you can understand that. Okay, so everyone, please post it in the chat in the data link layer. What are the protocols it is going to use to provide this multiple access services? Post in the chat. What are the two protocols just now I have explained which is going to be used in Ethernet? Bit oriented protocol and that. Post in the chat. Everyone, am I audible? Everyone, Jaranya, Krikar, Pratyusha. Yeah.
Yes, sir, you are audible.
Then why you people are not responding in the chat? What are the two protocols which we are going to use? HDLC and PPP. What is PPP? Point-to-point protocol. What is HDLC? High-level data link control protocol. What is the format of that? Which is going to start with address field, control field, data field, and your checksum, and which is going to have your frame check. Okay, starting of the frame, flags. Okay, now if we are going to look at your starting, see, this is what exactly 802.3. Please try to understand. This is what exactly the preamble, SFD. Okay, start frame delimiter. Now this start frame delimiter, you are going to use the flags. Okay, and preamble is the 56 bits of altering ones and zeros. Then you are going to use the 6 byte destination address, 6 byte source address, and your length or type is 2 bytes, and this is the data end padding, and this is the frame check sequence or CRC. 802.3 frame format. In your exam, they may ask this question very, very importantly. So which this is what I have explained to you people, that the maximum is 1500. Okay. Then minimum payload is 46. How 46? See, 6, 6, 12 plus 2. How much? 14. 14 plus 4, 18. Isn't it? So now 18, and this data maybe you can have 0. Isn't it? Then you are going to have 8, 8, 16. See, 7 byte, 1 byte, 8, 20, 26. And that minimum data and padding. Now, how much minimum payload you should have? 46 bytes. Maximum how much? 50, 1500. Now, this is, you please try to, you need to understand that minimum frame length should be 512 bits. Okay. And maximum frame length is this. Now, the point is the data is minimum is 46, maximum is 1500. Now, you need to calculate. Okay. So, 46 plus, okay, then 6, then 6, then 2, then 4. Now total how much it is coming? 12, 4, 12, 4, 16 plus 2, 18, 18 plus 46. Everyone, 18 plus 46, how much? 64. Getting my point? What is the minimum frame length? What is the minimum and maximum? This is what exactly. Okay. And that is nothing but, now here you please try to understand that your minimum payload length is 46 plus, and these are the 4 compulsory. 4 compulsory. Destination address 6 bytes, source address 6 bytes, length or type is 2 bytes, and your CRC is 4 bytes. Now, all together 18 plus 46, that is 64 bytes. This is the minimum. Okay. And then 1500, when you are going to take over here 1500 plus these are 18, so that is nothing but 1518. Okay. This is maximum. Is it clear? Okay. Then what is the MAC address? See, when we are going to talk about your destination address and source address, which we are discussing about, is 6 bytes. Okay. So that is nothing but, so we are going to use this 6 bytes hexadecimal, which we are going to use the 12 hexa digits. We will use, each one is going to be represented with 4 bits. Now that is nothing but, ultimately we are going to talk about the 48-bit address. Then we are going to have a unicast and multicast address. When you are going to have the least significant bit, when you are going to have 0, that is a unicast address. If you are going to have 1, it is a multicast address. Okay, you can have a look at that. The least significant bit of the first byte defines the type of address. If the bit is 0, that is a unicast. What is a unicast? Unicast is 1 to 1, and otherwise it is a multicast, that is nothing but 1 to many. Okay. So now when we are going to talk about a broadcast is going to contain all ones, all bits are ones, that we are going to call it as a multicast. That is nothing but irrespective, for everyone we are going to send it. Okay. So this is an example which we are going to have over here. You can have a look at that. And when you are going to look at the standard Ethernet, in the standard Ethernet, we are going to have 4 different types of implementations: 10 base 5, 10 base T, 10 base T, 10 base 2, 10 base T, and 10 base F. So you may say that, so what is this base, and also like baseband and broadband, which we have discussed, that low pass and high pass channels. And when we are going to talk about 10 base 5 and 10 base 2, which is going to use a thick coaxial and thin coaxial cable, and when you are using T, which is going to use star, and when you are using F, which is a fiber, and which is going to majorly use the topologies as bus and star. Okay, in this, when you are going to use in detail about 10 base 5, you will come to know that. Okay, in the 10 base 5, you remember in the earlier I have explained about Manchester encoding, data encoding standards. Okay, how line coding standards are going to be there. So in the 10 base implementation, what is the meaning of that? It can transfer at 10 megabits per second, and maximum cable length is 500 meters, and which is going to use the baseband. And now here, if this is a cable, now see here you can have that the transceiver cable maximum 50 meters, maximum 50 meters. Okay, this one from here to here, whatever the distance is there, this should not be more than 50 meters. Okay, so now, and when you are talking about this cable should not have a maximum of 500 meters. If the moment if the 500 is crossing, then what you need to do, you need to add a repeater. Okay, or you need to join. Okay, so like that you need to create this particular thing. So this is what exactly the 10 base 5. And here when you are going to use that, this is the BNC-T connectors which we are going to use that. Okay, now you can have a look at that. If you reverse it, if you reverse it, okay, which is going to look like this. Okay, you are going to connect it by using the BNC T connectors. Now here you can have a look at that. These are the BNC T connectors which we are going to use over here like that. So when you are going to use the 10 base 2, you are going to use 10 Mbps, and maximum is only 185. That is nothing but 200 meters. You can take it. Okay, 185 meters, and baseband digital. But only the point is here it is a thick. Okay, here it is a thick. That is the reason it is a straight line. You cannot bend it. But in the 10 base 2, what is happening? We are going to use a thin coaxial cable so that this bending is there. It is easily bendable, and you are going to use the T connectors as a connectors. Then another one is the star topology. We are going to use star topology when we are going to use, sorry, UTP, unshielded twisted pair we are going to use, and which is also going to use the baseband and 10 Mbps. Now here if you are going to look at that RJ45 we are going to use, and this is a hub we are going to use, 10 base T hub, and each and everything we are going to connect it. This is a two pairs of UTP cable. Okay, so which we are going to use. Okay, the unshielded twisted pair, you have remembered that. Okay, which we have drawn like this, and which we are going to have, okay, like this. So this is a unshielded twisted pair, like two pair we are going to use over here and to connect this particular thing. So at the same time, fiber, when it is going to be happening, the fiber we are going to use the 10 base phi hub. Okay, and here we are going to have two fiber cables, one for up sending and one for receiving for each station, and this is how exactly we are going to use. Ultimately, when you are going to look at this difference, always you can understand that which is little costly, because so we have to use two different types of cables. Okay, so the ultimately in the standard Ethernet, what you are going to use, you are going to use the thick coaxial cable, thin coaxial cable, two paired unshielded twisted pair fiber, and the maximum length you can have in the 10 base 5, 500 meters, 185 meters, 100 meters, and this is the 2000 meters. And line coding which we are going to use is all Manchester encoding which we are going to use it in this one. Always you please try to remember that we have discussed that zero, the DC component. Okay, we need to eliminate the DC component and synchronization. DC component and synchronization. Out of that, which methods are best? That method line coding we need to use, and this is the line coding which we are going to use in the standard Ethernet. Okay, so when we are going to change these particular things, then you are going to have the another one. Like if suppose here only the 10 base which we are going to have, this is a standard. Okay, when you are going to look at the other one, so fast Ethernet, okay, that is nothing but you are going to have the standards like bridged Ethernet, switched Ethernet, and full duplex Ethernets which you are going to use. But then when you are going to look at the fast Ethernet, you are going to have 100 base TX, 100 base FX, 100 base T4. Like these are the things, and which is going to use the different encoders, means which is more faster than, okay, more faster than your standard Ethernet. But we are going to make use of the standard Ethernet, and the same way we are going to use the Gigabit Ethernet, in the Gigabit Ethernet also we are going to use various types, okay, of the implementations. Okay, so this is what exactly we are going to talk about, your standard Ethernet, which we are going to make use of in our this. Okay, so everyone, you can have a look at, and which is we have already discussed all other things. Okay, any doubts in this? See, we are going to use the Ethernet switch for that. Fast Ethernet, fast Ethernet, switched Ethernet, gigabit Ethernet. So this is how exactly we are going to have in the switching techniques in your Ethernet. Okay, and then finally we are going to have the 10 gigabit Ethernet, and in this 10 gigabit Ethernet also you are going to have various types. Okay, and these are the cables which we are going to use for which purpose and all. So this is what exactly about your switched Ethernet or standard Ethernet, how it is going to be work. Okay, so please go through with that, and so that you can have more understanding. And here, if you are going to look at that, once again, I am showing the diagram. Ethernet evaluation is going to be done in the 4 standard, fast, gigabit, and 10 gigabit Ethernet. Okay, so any doubts? So HDLC frame or PPP, which we are going to have the frame format, preamble, then we are going to have destination address, source address, and then we are going to have control fields, and then we are going to have the data, and then we are going to have the CRC. And always, would you please try to remember that what is the minimum and maximum sizes are there in the frame. So minimum is 64 bytes and maximum is 1518 bytes. Okay, and data length is also it is there, minimum 46 and maximum 1500 only we can send it in one particular frame. And this particular thing is going to be supported by using the standard Ethernet, because see, in the previous class we discussed about the multiple access protocols and how these protocols are going to be supported by the hardware, where we are going to discuss, we have discussed about the standard Ethernet, okay, or fast Ethernet, and 10 gigabit Ethernet and 10 gigabit Ethernet, which is going to internally use those protocols to provide that. And please try to remember, in the LAN we are going to use CSMA by CD. Which mechanism? CSMA by CD. Carrier sends multiple access by collision division. Okay, so remaining things we will discuss in tomorrow's class. Thank you all for attending. Any doubts? Thank you all for attending. Any doubts? Yeah,
Sir,
Neeraj.
uh, I don't have doubt in the subject, sir. I have some doubts about the other subjects, like not other subjects, like kind of which I can ask you.
Please tell me.
Sir, where I am from R16 regulation, no, sir.
Okay.
So